The numbers 220 and 284 are a special pair of numbers known as an amicable pair. And this is because if you list out the factors of 220, which are just 1 and 2, 4, 71, and 142, and you add them together, you get 284. On the other hand, if you list out the factors of 284, which are 1, 2, 4, 5, 10, 11, 20, 22, 44, 55, and 110, you add those together, you get 220. It's very rare that this happens, that the sum of the factors, not including the number itself, of one number add up to something, and if you take that thing, that thing they add up to, and take the factors of that and add them together, not including the number itself, you get back to the first number. It's very unusual, and only one amicable pair was known from the time it was invented, this idea in 300 BC, and then for the next 1,000 years there were only two other amicable pairs known, until Leonard Euler came around and he single-handedly found 57 pairs, and I'm going to show you what his technique was for finding some of them. The technique is to first pick a number. This is, it could be any number. So for instance, if you pick the number 4, Euler says that if you take this number and put it into this formula, where you put a over 2a minus, and I'll explain what this symbol means in a second. So a is 4, 2a is obviously 8. This symbol means the sum of the factors of a. So since 4 has factors 1, 2, and 4, this weird symbol of 4 is equal to 1 plus 2 plus 4, which is 7. So this becomes 4 over 1. And we reduce that fraction. And we call the numerator b, and the denominator c. Now we work out, we make this expression, which is that cx minus b times cy minus b has to equal b squared. And Euler figured out, I'm not doing a proof of it, but showing you what his process is. If I plug in the c and b, I get 1x, c is 1, 1 minus 4, or sorry, 1x minus 4 times 1y minus 4 is equal to 16. Now we're going to make a chart, because 16 is the product of two things. So I'm going to make a chart of what x minus 4 and y minus 4 could be, so that the product's 16. Well, there's not that many ways to make 16. There's 16 and 1, there's 8 and 2, and there's 4 and 4. The next two columns are just x and y. Those are just these two numbers with 4, in this case, added to them. So 20 and 5. This one is 12 and 6. This one's 8 and 8. Now we do 3 more columns. P is going to be x minus 1. Q is going to be y minus 1. And something called R is going to be xy minus 1. And when you do that for all these, this becomes 19 and 4, this becomes 11 and 5, this becomes 7 and 7. I'm just taking away 1 from each of these numbers. And then if I multiply these numbers and take away 1, I get 99. 12 times 6 is 72, so that's 71. 8 times 8 is 64, that's 63. So there's a lot of numbers in this chart. You look for these three that are, if they're all prime, which they are, then we have an amicable pair with numbers m is APQ and n is AR. In this case, A is 4, so 4 times 71 is 284, and 4 times 11 times 5 is 220. Different a values can get pretty complicated, but that's how this process works.